Let me stop it. What do you tell me what you're doing?
Do a whole minus whole.
And you can do whole minus whole on a vertical axis. But think about it. If you're spinning it like this, look over here for 2 seconds. If you're spinning it like this, your radius is a change in x.
Mm-hmm.
And you would, to do that, you would have to solve for x in terms of y. And because you're stacking them up, you would have to change everything into x equal y equations to do whole minus whole on a vertical.
Right.
So for a vertical axis, what's probably your best bet? Unless you want to change it all, and you can if you want, except this direction said use the shell method. You just can't see it right up there at the top. So how do I do the shell? You know how to erase? Yeah. How do I do the shell method? Talked about it yesterday. You hear yesterday?
I just wasn't paying attention much.
Think, what did we do? Roll of toilet paper. I pulled out the shell. What was it in the shape of?
Rectangle.
Rectangle. And what was the length?
The base.
Hold on. Think about the shell. Look at it over here. You had the shell, right?
Yep.
When I peeled it off, the length was formed by the what?
Radius.
It used the radius, but what was that?
Circle.
And that that circle, when I unfolded it, the what of that circle was the length?
Diameter.
Circumference. You remember circumference?
2 pi.
What's the formula of circumference?
2 pi r.
2 pi r. So you're starting with that, 2 pi. Now, how do I find the radius? And the radius is the length from that axis to all the little edges of the shells. What was the trick I told you?
It's like this with that. This was x, right?
Right?
And this would be 5 minus x.
Good. So, and the trick on that is what? Either axis minus the x or x minus the axis. And we go with axis minus the x when your axis is to the right. So what he has right now is 2 pi radius. So he has, hold on, get rid of the dx. He has the length of the sheet of paper towel. Now, how do I find the height of that paper towel so that I can get area? What would the height be? Okay, so what is that?
Just be just 4 minus x squared minus 0.
Good. You really don't need the minus 0, do you?
No.
Now stop right there. That gives you length times width, which is area. But we're doing volume, so what do you have to do to make it volume? How do you give it a little width? Dx it?
Yeah.
And then what are your sheets being pulled from what x values? From what to what?
0 to 2.
Is it just 0 to 2? Look at the shaded region in blue.
So we got negative 2 to 2.
Yeah, if that's the shaded region.
Okay.
Y'all seeing that? Okay, so that shell, could I do that with dishwasher? Sure. If I want to take that equation and resolve for x in terms of y, you're going to get 2 equations. You're going to get a positive one and a negative one, and you're going to have to use both of those, and you're going to have to do a whole minus a whole. So to me, it's much more work, which is why I'm giving you the shell method. You do not need to know it on the AP test. You don't. But it'll make your life easy in a situation like this all day long. In fact, I'm not going to say in every situation. There are some situations where on a vertical axis, like what if AP had given you this? They give you a vertical axis, and they go ahead and give you that equation. They say, hey, that's the equation you're going to be using. It's like, here it is right here. But there's your bounded region. But there's your equation. In that case, on a vertical axis, I don't know how to solve for y in terms of x. I can't do it. So I'm just going to roll with it and do washer. Because it's already in terms of y, right? So doing a dy is not a big deal to me. But you got to know both methods. But a lot of times you're going to see the shell is really helpful on these. All right, same thing. I'm going to set up the picture real quickly. I've got an x squared plus 1. That shouldn't be a big deal for you guys. Write a parabola, shift it up one. So I know I've got this. It's probably not that wide, but I like it wide for this picture. I've got x equals 0. Yeah.
On the previous question, like where'd you get the 5 minus x equation from?
Okay, so on the previous problem, the picture looks something like this, right? Okay, and remember, we're rotating this thing over this axis. So when I rotate that shape over this axis, it makes a giant bundt cake. Are you kind of able to see that? So what I need is the radius. Well, each shell on this thing, the shells start really small, right? I'm peeling the outside layers off of this big bundt cake. I don't even know how to visualize that. Maybe like I mentioned a cheese a cheese slicer. You sliced off a thin layer on the outer part and kept slicing off thin layers. Eventually, the thin layers would go back and you'd finally be gone and there'd be no cake. You kind of seeing that? So each little strip is going to have a big shell right there as you pull them off, okay? So on each of these right here, each of these shells, you've got a side to the shell, right? As you go around, I need that length, okay? So if I just use x, the x gives me the distance to there. Well, I'm sorry. That's not what I want, is it? I'm sorry. If I use the x of that, that's not true. If I use the x, it gives me the distance to the right there, to the edge. So right here, this would be the x. But I clearly don't want x, right? So what I do is I go 5, right? 5 gives me this distance. And then I go minus the x. And I take 5. Hold on. Let me make sure I get this right. Yes. And subtract the x. Well, the x was a negative number over here, wasn't it? So when I subtract the negative number, like say x was a -2, I go 5 minus a -2, it gives me 7. And that's the length. And so over here where it's negative, I end up getting bigger than 5 radius. When it's over here, I end up subtracting a positive number, ends up being smaller, and it never gets any smaller than that. So I just go all the way through those x values. But I don't want to overly think about it. I want to just be able to get it. So if I just say, hey, axis on the right, 5 minus x. Axis on the left, x minus 5. I'll always have that radius. You can free up your brain to think about harder problems. Does that make sense? Okay, jump to number 2. We need somebody to plug this on our calculator, but here's my picture. I've got an x squared plus 1, which is going to look something like that. I've got x equals 0. What is x equals 0? It's the vertical line, right? Not the x-axis. It's the vertical line. So that goes right here. I also have x equal 2. We'll call that right here. And I have y equals 0. We'll call that right here. So here is my shaded region that I'm using. And since this was x equal 2 and that was x equals 0, I do know where I'm beginning to end if I do this kind of a rotation. Are y'all with me? Now, I'm rotating it about, what does it say to rotate it about? -3. Okay, so we'll make this the -3. Now, let me just talk to you real quickly. There's my -3. Think about disc washer. If you didn't have shell on the AP test, which they're not expecting you to know, they might give you this and go, ooh, tricky problem. You're going to have to do whole minus whole. But look at what happens right there. The axis to outer here is the same. Axis to inner is the same. But then you get up to here, and the axis to outer is unchanged, but the axis to inner is changed. To do disc washer on this problem, you would have a 4 integral situation. You'd have, at least 3. I guess you could do the whole all the way through here, and then subtract this part of the HOLE, and then subtract that part of the HOLE. But it'd be a nightmare. Disc washer, 1 integral. It just makes your life easy in certain circumstances when you have a vertical axis. So right here, here's your situation. Pass it on to the next person. You pick whoever was last.
Alan, you got it.
That's probably. You get 5. What's the distance from -3 to 2? So do I just put -3 in?
Is your axis always going to be?
I did it from the 2 to the -3, and I just knew that distance is 5.
Yeah, but is that what you want?
No, over 2 to 0.
Let me give you an example.
Loss.
Okay. So like if you rotated this about this axis, right? This is always your little edge of your shell is always going to be changing, right? Sometimes it's there, sometimes it's there, sometimes it's there. As you peel off shells this way, right? Or from the inside, whatever. You want that distance. Say you want this one. This distance from here to here is your x coordinate, x, right? It's always x. This distance is clearly always 3. So what I really want to end up with
X
is
plus 3.
x plus 3. But how did I get that? X minus the axis, and I don't have to think. So x minus the axis, axis minus x. Every time, and you don't have to think about it. If you think about it, great. I'd love for you to know why, so you explain it to somebody. But the bottom line is, right here, if you just go x minus the axis, and you can change it to a positive 3 if you want. Great, your thoughts are over. And when the axis is on the right side,
Okay.
axis minus x. All right, the 2 really never comes into play. The only time the 2 comes into play is on that very outer one right there. X happens to be 2, doesn't it? And then you get 2 minus -3 is 5. That's the only time it's a length of 5. Every other time it's a little smaller than 5, all the way going down to where it's just 3. But don't think x minus axis is your radius, or axis minus x. And truly, then it becomes the easy problem, top minus bottom. Okay, where'd you get that?
I did x squared plus 1 minus 3, which would be plus 3. It would be x squared plus.
Why? What does this stand for right here?
Oh.
All right, this is your
So it'd
What?
be x squared plus 1 minus 0. So just
minus 1 plus 0, plus 1 minus 0, right? So just x squared plus 1. Y'all see what's going on? What is this right here that I'm circling? What is that finding for you? It's circumference, but what is that finding?
base.
Here's your shell, right? When I open that shell, peel it off, what did 2 pi r find me?
Base.
The base of the height, the base of the length, right? That's that. What is this finding me? And the height is that, right? Because you have this shell, that's finding that height, top minus bottom. You just don't see the -0 because you don't really need it. Y'all with me? All right, pick your next victim. I'm going to sketch this out real quickly.
I think Christian's got it.
I've got y equals x squared looking something like that. I got y equals 4x minus x squared looking something like that. Here is my region. And I'll even give you the courtesy, these cross at, hold on. At 2, 0, and at 2. I'm gonna throw that in there just for fun. See if you know what to do with it. And we're rotating at about x equals 4. So I really don't need all of this junk. So I'm rotating that shaded figure about this line right there.
Wait, how do you raise?
Um,
I'll just do this.
do y'all see that? Other than copy, he didn't copy the problem down, right? What's your function on the top?
Of 4 minus, or like, that's 4 minus x squared.
No, look at it.
Oh.
What is it?
What do you mean?
Look at the equation.
Y equals x squared.
Look at the other one.
Y equals 4x minus x squared.
Look at it again. For what?
X. Oh.
Yeah, don't do something like that. I can't see him taking off a full point for that. They'd probably take off a half a point. I'd probably take off a half a point. But my problems are 10-point problems. Their problems are 2-point problems, right? And that would cost you to miss your answer if you had to type it in your calculator. So be careful about that stuff. I have a question. Why did you go from 0 to 2 and not 0 to 4?
Because the shaded area, like the region that you're actually. No.
Right, but why do I go 0 to 4 on whole washer, but I don't have to do it here? I know there's a hole in whole washer too, and disc washer too. Why do I go 0 to 4 on disc washer, but I only go 0 to 2 here? I'm only concerned with the shells. I don't overdo it like Wahole does, and then get rid of what I overdid, right? I'm just peeling off the shells. When your toilet paper roll is done, you keep grabbing air and trying to peel off the toilet paper that doesn't exist. No, it's done, right? So good. From 0 to 2 is the only place these shells would ever exist. Are y'all visualizing these shells? Or are y'all just memorizing how to do it? Which either works. But y'all do know what you're doing? Yes, no? Like right here. What's really happening here, if you have forgotten already or missed a day, there's actually this region over, like you have this region, right? Like there's all of this, or is basically this big, weird, funny ring looking thing, right? That's got this width that's been brought all the way around. And I'm peeling off these layers, right? Each layer through here has a shell that goes with it. Right? And I'm peeling off the layers of these shells. Starting on the outside, they're really thin, and they work my way up right through here. But the second I hit right there, there's no more shell, right? It's like a roll of toilet paper. I can keep peeling off stuff, and then I get down to, assuming I took the little cardboard thing out and threw it, as I'm peeling off the toilet paper, at one point, the last shell comes off and there's nothing there, right? So it's unlike discs. Discs, I'm doing a cross section and finding the whole area of the circle and then going back and getting rid of that area. To find the whole area, yeah, I'm looking at the entire distribution from 0 to 4. But here, I quit pulling off rolls the second that value hits the 2, x equals 2. The second x hits 2 right there, that's a radius of 2. There are no more shells that have radius of 2 or less. I don't need to pull those off, right? It just makes no sense because there's nothing in the middle. And I'm not overdoing it and then subtracting what was overdone. So what did I do by doing 2 pi 4 minus x? That was the what? Was the length of my sheet of toilet paper or sheet of whatever. What is this doing? Top minus bottom. That's finding the height of that shell. And then that times that gives me area. Give it a little bit of thickness, creates volume. Count up all the volumes that you get as x changes from 1 to 2. And that creates the total volume. From there to there. All right, I am jumping to some different ones. Some of this is homework. Thinking about the radius worksheet, we're going to jump to this. Pick your next victim. Oh, and by the way, this might jump you in back into dishwasher. You decide.
Okay, wait, so I need to make it a washer thing, right? For this.
If it's a horizontal
Since-
axis, I tend to lean that way, yes.
Okay.
I'll not lean that way. I don't know that I've ever done a shell method on a horizontal axis since 1987. So I don't see the
Okay.
need to do it because disc washer works great.
Okay. Is this gonna,
Think in terms of big R and small R, if
Yeah.
that triggers something.
okay, and then do I need to do the Y values as these, or it's solved in terms of the, so I should.
So if you're gonna use the equations x minus 3 squared minus 6, right, then you're
Yes.
gonna want a dx. It's gonna be all x stuff.
Okay. So,
Good stuff.
okay. And then, wait, it's the IRs. And
Don't forget the minus 6. It's kind of hidden.
yes. Okay, so now I have to subtract the inner part. Okay. So,
Do me a favor. Draw in your big
Confused.
R and your little r. Just
Okay.
draw a little line and show me where they
wait, so
are.
it's being rotated on this, oh wait, this axis.
Well, that's what I did by mistake.
Oh,
And that's
wait,
what
no,
will
this
crush your
axis?
soul.
Okay,
Yes, the x-axis
okay,
is the
that's-
line,
That's
yeah.
what I was doing, okay.
Yeah. Like I accidentally did that to show them this example
Yeah,
right after saying to them, be careful and don't confuse your vertical lines of rotation or your whole problem's dead. And then I did it. And I wasn't even kidding. Like it's so easy to do that. And if you do that, the whole problem goes south.
wait, so this is the,
That's your little
Little
R
R,
and that's
and
your
then
big R.
that's
So
the
do
big
you
R.
have the right big R in there?
no,
What should it be?
it should be the. Wait, I'm confused how to use the X values to like do this way.
Well, here's the thing. This is another thing that's confusing. Do I really want X values? What I want is to take the top Y value and the bottom Y value and subtract them to get the change in Y. But what's Y equal to? The X stuff. So I'm using the X stuff in its place as a substitution for top Y minus bottom Y. But since Y is equal to 0 and Y is equal to that function, I use those. We'll get to that in a second. Yes. She's going to be lucky here and be right because of the laws of mathematics. But yes, you are correct. It should be.
I keep doing that.
Okay, so real quickly, let's take a look at what she's done. She did the same thing twice. I would not count off. I'm pretty sure AP would not count off. but not because she is technically right, because she's mathematically right. So right here, look at your big R. What do we normally do to find the length? We take the top minus the bottom. What is your top
Yes.
function?
The sit or the top would be the 0.
0.
Yeah.
So you really should be going 0 minus that, shouldn't you?
Yes.
But you got lucky because
Oh,
what?
it's square.
You're squaring it. But
Okay.
technically, it ought to be
Yeah.
minus that function squared. Again, I'm not going to count off because it's mathematically right. And if it's a multiple choice question, your calculator is going to spit out the right question. the right answer. But you're going to be wrong doing right minus left or top minus bottom if you get that messed up on the other methods because there's no squared on the shell method. And then in the other one, same thing. What's top minus bottom for your little r? Wouldn't it be 0 minus a -2 or positive 2?
Yes.
But for the same reason, she's going to get bailed out by math in this case because I'm squaring it. But I would be really careful on that, guys, because kind of like the distance formula. Remember the distance formula? You're going x minus x squared, minus y squared. Doesn't really matter which way they go in because you're squaring them. So what if you get them in the wrong order? So that's kind of true here. But from a technical standpoint, that ought to be plus right there. That ought to be a plus. And this ought to be what she has right there, a little minus in there. Are y'all with me on that? Yeah.
Do you have to include the areas where the curve is on the bottom for the second part of it?
This is my shaded region. If this is answering the question, that's my shaded region right there.
Yeah, but when you subtract energy, you have to include on the side.
There and there?
Yeah.
No.
On the inside.
Oh, right in here?
Yeah.
No, because it said bounded, and the only thing that is completely surrounded or bounded by those two is that. If it had said between and gave you an interval, like what if I said in between on the interval from 0 to 6? Well, then you would have also had these. That would have been a totally tricky problem. And then I would have probably changed the axis to something else or whatever. You know, that would have been totally tricky. Typically on volumes of revolution, you're not having to switch the outer and inner and stuff like that. You really aren't doing a lot of that. Are y'all with me so far? All right, what about same thing? I'm going to copy down the equations, x minus 3 squared minus 6. So your equations were x minus 3 squared minus 6 and y equals -2. Those were your two equations. We're rotating about y equals -7. So here is my axis of rotation that I'm rotating this about. Pick your next guy.
I literally looked at you and I was like shaking my head watching her. Oh. Oh, wait. Wait, what was the equation again?
It's right up there in the red, right above there.
Oh. I'm just gonna fix the middle.
There you go. That's fine. Y'all tracking? And keep in
Is
mind,
that right?
that's good.
Okay.
All right, she did what hole? And she went what? Outer to axis. Outer was -2 minus the axis is -7. gives you a total of what? 5 every time. And you can see that axis is never changing, is it? From the outer to the axis is always 5. And when you simplify that, that's always 5. So pi 5 squared. If you were doing a multiple choice question, you're not going to see this, right? What are you going to see? Pi integral what? Now right here, what are you going to see? Pi that, what are you going to see for this? Probably not even 5 squared, probably just 25 dx. Are y'all seeing that? So I'm fine if you set it up that way. So is the AP test on the multiple choice. I'm the free response, but on multiple choice, they're going to clean up the answer a little bit. And then over here, kind of same kind of thing. Are you going to see minus a -7? You're probably going to see +7. So just know that they're not going to foil all that junk out. And it's also possible that they go x minus 3 squared, that -6 plus 7, they might just do what? +1, because -6 plus 7 is 1. So look for those ways they simplify when they're writing their answers as options for multiple choice, because I will do that occasionally on my test, have multiple choice answers. And I know on the AP test and on all of our practice tests, which you'll be graded on some of them, you'll see that kind of stuff. You'll get used to it. But anyway, good job on the thinking right there. What about this? Jump into the other page. All right, same thing. And let's do this. I just picked somebody. You get the power. No, I don't feel bad. That's right.
Oh, yeah, Mr. Hurd.
I'm good. Don't make them make you feel bad.
Sure. Do you really know? Or see you on it? You can, okay, you can, yeah, I don't.
Now, notice I switched gears here, and now we have a what? We have a vertical axis again. And by the way, this is a great example of why I give you the shell. Because this problem, if you do it with disk washer on this vertical axis, you got to go through all the pain and suffering of resolving that in terms of x. You're going to get 2 answers, 1 plus 1 minus, and it just becomes a mess. And you got to do what whole minus whole. This is where the shell bails you out. AP thinks they're giving you a tough question, and you're like, dude, it's just a shell method. You don't have to do any changing, any resolving. You don't have to have it in order.
Oh.
Yeah, so you can put it in order if you want. Did y'all catch that? She had put the height in there before she did the radius. That's fine. I mean, it doesn't really matter. Missing one little thing. Look back at your height. What is the height there? There you go. What do y'all think? Are y'all seeing that? Doesn't that feel a whole lot easier than having to deal with solving for x in terms of y, going in there and doing a whole minus a whole? I mean, it's just a mess. So that's why we're doing the shell. It's not required for AB, but it makes, like, literally, this is what I would have to do. I would have to solve for x. Check this out. Add the 6. Square root both sides, which gives me a plus or minus, and then add that 3 over. So this is what AP would be asking of you without shell. You would have to come in here and go, okay, this is the x equals the 3 minus the square root of y plus 6. This is the x equal 3 plus the square root of y plus 6. Are you tracking me with me? And you would have to go, all right, I got to do a whole minus a whole. So I would have to say, okay, pi, this outer to axis would be that minus the -2 squared dy. And then I would have to come in there and go from y to y, from -6 to -2. And then I would have to go minus the inner, which would be the negative version, 3 minus, and then minus the -2 squared dy. Are you seeing the extra effort that you go through? Did that feel comfortable at all? Now, that's what I'm saying. If you have, now, if they gave me the problem already solved for y, for x in terms of y, I'm like, oh yeah, big deal. I can do dishwasher. But there's so much more work. Like that, they would consider that a tricky problem. But with shell method, it's just, if you just know how to do it, it's just child's play. Makes it so much easier, I think. All right, what about this? We're rotating about that axis. And again, your equations were x minus 3 squared minus 6 and -2. You sure up. It's great. You wouldn't get counted off this. You're missing an extra parentheses around that -6, I think. But yeah. Y'all seeing that? And if you do these enough, you get to the point when it gets to radius, you're not really even thinking anymore. I mean, if you want to think about it, yes, your radius is not the length 7. That's the whole thing. But when you rotate this, there's some shell, right? Your length is the 7 minus whatever the x value of that was. 7 minus x. And that leaves you this radius as it's changing. So that's the radius we're using. It's the 7 minus that part. And it just figures itself out. And you don't have to think anymore if you just go axis minus x or x minus axis. And then this is just top minus bottom. And I like that the last 2 people up on the board did a good job with their parentheses in there, because you're minusing the whole thing. This is a common mistake. Can y'all see this, what I did wrong here? I'm trying to subtract all of that, but what did it look like I did? Just subtracted the first part, and I never ended up subtracting the -6, did I? Now you can fix that by just changing the sign, but getting those parentheses correct in there is a good thing. That's all I got. I think your homework was to fill in some of the rest of that stuff, some of the ones we skipped. If you're feeling really good about this, guys, we still have 2 more days of review. It's so not necessary, okay? So this was, I told the other class, it's probably a little harsh, but if you don't do well on this, look in the mirror. It is on you, okay? We got 2 more days of review for our test. Don't forget we have a 9-week test next week too. You might want to start reviewing that. It will not have this volume on there. We're just a couple days ahead. That's the reason normally we have to take the 9 weeks before the volume test. But everything else, and this has been a huge 9 weeks with a lot of material. If you wait till the night before, that's probably not going to get you in a position to drop your lowest test grade. And I'm hoping you can do that if you have a rough one.
Miss Brooks and Jen.
She did what she's, I forget what it was. I was okay with it, but
Okay, I'm gonna have to get a few minutes or 10 minutes earlier from class.
when is this? Yeah, sure.
I'm just like, get everything ordered.
So you're fine.